I want to have a quick look and a quick compare of combustion cycles and formation cycles to sort of emphasise some of their differences. So on the left here, you can see a combustion cycle, and it has the combustion products, so carbon dioxide and water at the bottom. And the aim of this cycle would be to work out the enthalpy change for this reaction here along the top, which in this case is the enthalpy of formation of methane, but it could be any reaction. And the important thing about the combustion cycle is the arrows come down, and that is because the reaction goes from these reactants here, and they're being combusted to form these products here. So this arrow here on the left represents this reaction. So carbon and hydrogen reacting with oxygen to form carbon dioxide and water. I should have put my state symbols at the bottom here. This reaction on this side, again, it's combustion, this time of methane, and this one represents methane reacting with oxygen to form carbon dioxide and water. So the same products from both of those reactions. The reason that we balance them at the bottom is because when we're thinking about what enthalpy changes are involved, in this reaction here, we've got the enthalpy change for one carbon and plus the enthalpy change for two hydrogens. So it's worth at the bottom balancing them, just to remind you that you need two for the hydrogen and only one for the carbon. So the combustion cycle has the arrows going down, and if we think about that in a slightly simpler way, we could say that all of this was delta H1 and all of this over here is delta H2. And then to calculate our overall enthalpy change, we would be going the correct way down this arrow. So going down this arrow represents the combustion, so we leave the signs as they are. And then we go the wrong way down this arrow, so we would do minus the delta H2 because we are going the wrong way down that arrow. And then if we put in the more specific examples, so delta H1 is the enthalpy of combustion of carbon plus 2 times the enthalpy of combustion of hydrogen, because we've got two hydrogens making two waters. And then minus the delta H2, which is this one here, and that's the enthalpy of combustion of methane, only one of those because we've only got one methane. If we compare that to our formation cycle, so our formation cycle has, in this case, it's actually a combustion reaction along the top, but the important thing about the formation cycle is it's got the elements that the compounds are formed from down the bottom. In this case, carbon, which is a solid in its standard state, hydrogen, which is a gas, and oxygen, which is a gas. Again, it's worth balancing because it helps to show how many of each type we're being formed. So we have two waters being formed here from these two H2s, and one carbon dioxide from this one carbon. You'll probably get the right answer if you don't balance it down the bottom, but you won't necessarily get all the marks for drawing your cycle in an exam question. Again, we can have a look at maybe simplifying some of these enthalpies just to have a think about how it's different from the combustion cycle. So if again we make this delta H1 and this delta H2, and then we look at how we calculate our overall enthalpy change. In this case, that's an enthalpy of combustion, but it could be any reaction across the top. This time, we are going the wrong way down the arrow. So, because our arrows are the opposite way round, we are going the wrong way down the arrow. So we do minus delta H1, and then we go the right way down up this arrow, so plus delta H2. And so you can see, if you compare the combustion cycles and the formation cycles, if you don't draw the cycle and look at the arrows, you can end up making a mistake, because you have the negative of a different one because the arrows are a different way up. So if we put in a bit more detail there, that would be minus the enthalpy of formation of CH4 plus the enthalpy of formation of carbon dioxide, and 2 times the enthalpy of formation of water.